Hello everyone and welcome to Keeping Tabs on Chemistry. In this video, I'm going to be going over the ideal gas law. Now, the ideal gas law is a really interesting and very special gas law. So if you were to take the combined gas law, P1V1 over T1 equals P2V2 over T2, if you were to use conditions at STP, we know the pressure and the temperature from STP, but we can also use molar volume for the volume of 1 mole of gas under those STP conditions. And we can calculate some constant which we call R. So if I were to use 1 atmosphere, 22.4 liters, and 273 Kelvin, I get 0.0821. I could also do this in kilopascals using standard pressure of 101.3 kilopascals times 22.4 liters over 273 Kelvin and get 8.314. R is what's known as the universal gas constant, or sometimes the ideal gas constant, or just the gas constant. So the value in units of the ideal gas constant depend on your units of pressure. So there are different values for R just depending on which units of pressure you're using. So you could memorize just one R and always convert to, say, atmospheres, or you could just convert your units of pressure to whatever units of R you have. So going either way, there are different R's depending just on that unit of pressure. So the value of R is calculated assuming 1 mole of gas. That's why we can use molar volume. But what if you had something other than 1 mole? Well, using what we know about dimensional analysis, we would have to multiply the molar volume by the number of moles, which would multiply our value of R by the number of moles, which is represented by a lowercase n. We don't use m because m looks like mass, so for moles we'll use n. So now if we rearrange this, we'll multiply both sides by T to get the final version of the ideal gas law that allows us to perform calculations of any combinations of these conditions. It's PV equals nRT. This is the final famous version of the ideal gas law, and it's affectionately referred to by chemists all over the world as PIVNERT. So the units within the ideal gas law, the P here is for pressure, and it could be any units of pressure that matches the R. The volume is in liters this time, and it has to be in liters. N is for moles. R is that universal gas constant, so it's either 0.0821 liter atmospheres mole Kelvin or 8.314 liter kilopascals per mole Kelvin. So you'll notice this volume has to be in liters because R is in liters. Your pressure would just match up with whichever one of these you have, or vice versa, your R would match to whatever pressure you have. And temperature is going to have to be in Kelvin for the same reasons why in the gas laws it had to be in Kelvin. So if I have 4 moles of gas at a pressure of 5.6 atmospheres and a volume of 12 liters, what is the temperature? So looking at this, how do you know that you're dealing with the ideal gas law and not some other gas law? Well, if you look at the variables that you have and what you're looking for, I've got 4 moles, that's N, a pressure of 5.6 atmospheres P, a volume of 12 liters V, what is the temperature T? I have 4 different variables here. The only gas law that deals with all 4 of those variables is the ideal gas law. So when I plug in here, my pressure is 5.6 atmospheres. This is already in liters, good, 4 moles. Now the R I want to use is the one in atmospheres, which is 0.0821. And then my temperature is my variable X. So when I solve for my temperature, I get 205 Kelvin. Here's another example. I have an unknown quantity of gas. Okay. A pressure of 121.6 kilopascals, volume of 31 liters, temperature of 87 degrees Celsius. Whoa there. I don't like Celsius. I'm going to convert that to Kelvin, adding 273. I get 360 Kelvin. How many moles of gas do I have? Right, so that question mark for N. So I've got PVNT. The R I'm going to use here is the one in kilopascals. So 121.6 kilopascals, 31 liters. N is my variable. This time the 8.314, remember those kilopascals match, and 360 Kelvin. So when I solve for N here, I get 1.3 moles. And that is going to conclude our lesson on the ideal gas law.